Welcome to This Explainer. Today we are going to completely unravel a massive and honestly fascinating illusion. You know, when you type a complex question into an AI, it really feels like there's a mind in there, right? Like it's reading your words, understanding your grammar, and absorbing your actual thoughts. But the reality of what's happening inside that neural network is completely different. And frankly, it's a lot more incredible than just reading text. So today, we're going to map out the true journey of a prompt and solve the mystery of how large language models actually process our information.
Okay, let's dive right into this. Does AI actually understand the text we type? Take a second and just think about what happens when you hit send. If you ask an AI, "Hello, what is artificial intelligence?" you see your words pop up neatly arranged on the screen. And it's incredibly easy to assume the computer is seeing those exact same words. But what if I told you that the entire system you're interacting with is fundamentally, literally, 100% blind to human language?
Think about the heart of the problem here. On the human side, we've got a cohesive, meaningful sentence that any English speaker can instantly read. But on the computer side, things are drastically different. The letters just vanish. They're completely gone, replaced by a raw string of numbers, 1024, 583, 921, and so on. Computers don't have eyes for language, you know? They only process data in the form of digits. So how in the world do we bridge this massive gap between our nuanced, messy human language and their strict, unyielding math?
That brings us to Section 1. What are tokens? The slicing process.
So, we need a bridge between text and numbers. And to get text into a neural network, we use a vital component called a tokenizer. You can kind of think of the tokenizer as an incredibly aggressive translator that chops our human language down into smaller computational base units. And these units are called tokens. Take a super simple sentence like, "I love AI." When the tokenizer steps in, it aggressively slices it up into "I love AI." And pay attention to this part. Even the period at the very end becomes its own distinct token. But a token isn't always just a direct equivalent to a whole word.
And this brilliantly illustrates how flexible and sometimes totally unpredictable tokenization really is. Think about the English word artificial. Because of how the model learned language, the tokenizer might split it into two completely distinct tokens, arty andficial. Now look at the Chinese translation for artificial intelligence. Because Chinese lacks those distinct spaces between words that we rely on so heavily in English, the tokenizer employs a completely different slicing method, chopping it into 4 individual characters, ren, gong, ji, hui. So really, a token is simply the fundamental building block that a specific AI model uses to represent fragments of text.
Section 2. Tokens are dictionary indexes.
Now that we've sliced up the text into these jagged little fragments, where do they actually go? Well, they need to get their mathematical identities. Once we have our tokens, the model assigns each one a specific numerical identifier known as a token ID. Every single AI model possesses this massive master vocabulary dictionary. It's essentially a giant lookup table. So the token fragment hello might be assigned the specific index number 15339. The token world might be mapped to the number 1917. The neural network never ever sees the letters HELLO, it only receives the integer 15339.
But wait, we really need to dismantle a major myth about how this works right here. I want to deliver a very strong reveal. The number 15339 does not mean hello. That number contains absolutely zero inherent meaning of a greeting. It doesn't carry the warmth of a welcome, the context of a conversation, or even the dictionary definition of the word.
To really lock this idea in, think of token IDs exactly like the call numbers on a library shelf. If you use a computer at the library to look up a textbook on computer networking, the system might give you the call number 3021. But the number 3021 isn't the book itself. It tells you absolutely nothing about how routers or Ethernet cables actually work. It simply tells the library system exactly where that item lives on the shelf. The token ID is just a pointer. It gives the AI a location, but it gives the AI zero understanding.
Section 3. Mathematical meaning, also known as embeddings.
Now, what's really interesting about this is if the ID is just a dumb location on a shelf, how does the AI actually comprehend what we're saying?
Well, to inject actual meaning into those raw numbers, the system converts that token ID into what we call a vector or an embedding. Imagine this massive multidimensional coordinate system, just a huge mind-bending mathematical space. In this space, concepts that are semantically related, like a cat and a dog, are mapped physically closer together mathematically. A car or an apple would be plotted much further away from those animals. This mathematical proximity, grouping ideas by their location in 3D space, that is the real magic where language transforms into computational meaning.
Now you might be wondering, and it's a very logical question, if it all turns into math anyway, why don't we just assign one massive ID to an entire sentence? Well, think about the combinatorial explosion of language. If I want to eat an apple today was one token, and I want to eat an apple tomorrow was a completely different token, the model's dictionary size would literally explode to infinity. By breaking text down into smaller tokens, we give the AI these recombinable Lego pieces. It can efficiently reconstruct any possible sentence in the universe from a finite set of building blocks.
Moving right along to Section 4, Tokens and Compute Cost.
This efficiency we just talked about, it isn't just some abstract theory for computer scientists. It grounds us right into real-world reality because it directly affects your wallet. If you've ever used a commercial AI API, you know for sure that pricing is not based on your word count. It's billed strictly based on the volume of tokens processed. A standard request might run you a few cents per 10,000 tokens.
Let's map out the direct pipeline of why that happens. The length of the token sequence you input in Step 1 directly taxes the hardware. A larger pile of input tokens demands significantly more GPU resources and memory in Step 2. Processing that heavy memory load naturally requires more compute time in Step 3. And as you'd expect, more compute time perfectly translates into a higher dollar cost in Step 4. Tokens are, quite literally, the currency of AI processing.
But here's the catch. We absolutely must clarify that not all text is created equal. 1,000 Chinese characters does not perfectly equal 1,000 tokens. As we saw earlier, tokenization efficiency varies wildly. An English technical article might tokenize very neatly, whereas complex programming code like Python or unique symbols or non-Latin languages might slice into a massive amount of fragmented tokens to represent the exact same underlying meaning. This is exactly why different text inputs consume the AI's context window at totally different rates.
Section 5. The language model's full journey.
All right, we have journeyed deep into the machinery. Now it's time to pull all of this together and synthesize everything we just learned into one cohesive picture. Here is the exact path your prompt takes from your keyboard straight through those deep mathematical layers. Step 1, human text is input. Step 2, the tokenizer fiercely slices that text into tokens. Step 3, those tokens are translated into numerical dictionary index IDs. Step 4, those IDs are plotted into a massive mathematical space as vector embeddings. Step 5, only now does it enter the transformer, the actual deep neural network layers that process the context and grammar. And finally, Step 6, the AI spits out its prediction for the very next token.
So the absolutely crucial point here is this. A token is not understanding. It is just the basic building block before entering the AI's brain. Generating tokens is really just prepping the raw materials. The true semantic processing, the actual thinking and relationship mapping of words, that only happens much later in the architecture, long after the slicing stage is completely over. Which leaves us with a truly provocative cliffhanger. We know it all becomes raw mathematical vectors, but how does the AI actually know that a router connects to a network? How does it know that the word apple in one sentence might mean a fruit, but in another sentence it means a giant tech company? Did human engineers really sit down and manually program those millions and millions of semantic connections? Well, the answer lies in the mind-bending mechanics of transformer attention, and that is exactly the fascinating mystery we are going to unravel in our very next explainer. You absolutely will not want to miss it. Keep learning, and I'll see you then.